Okay, so we're going to take a look at example 7 from the book, and we're going to take those rules we just learned and we're going to apply them. So let's start with the equation from the example. Okay, and the first thing we should notice is that we have a negative in front of this grouping here. We can apply De Morgan's law and move that negative in if we flip this and to an or. Okay, the thing that should jump out to us now is we have a double negative here, right? 2 knots in front of the Q. Double negative, that can be removed entirely. At this point, there are a few different things we can do. We're going to follow along with what the book did, and at this point, we're going to distribute this not P or Q into our P or Q over here. All right, once we've done that, I don't see anything obvious, but let's kind of reorder some things. Remember, according to the commutative rule, we can change the order of our statements. So let's go ahead and first let's move P to the front of this first statement. Okay, now let's go ahead and move Q to the beginning of the second statement. And finally, let's go ahead and flip P and Q here at the end. Now we can apply the absorption rule. Remember, Q and Q or P is the same as Q. Because if Q is 0, then because this is an and, the whole thing must be 0. If Q is 1, because it doesn't matter what not P is, this will be 1. 1 and 1 will be 1. So whatever Q is absorbs the rest of this. So we can get rid of that. Now we can go ahead and distribute P into this statement right here using the distributive rule, ironically enough. All right, once I've distributed, we see that I have P and not P. Remember, P and not P must be 0, right? Remember, according to the bound rule, 0 or whatever is whatever, because it's an or, so that 0 doesn't really have an impact. If this is 0 or if this is 1, that's going to be the outcome. So at this point, I think it's pretty obvious what I have. The official rule, I could use the commutative rule to move things into the correct order, and then I can use the absorption rule. But basically, I have Q or Q. All right, so I'm going to kind of spell out what they did in the book. First, we're going to use the commutative rule to get everything in the correct order. So this, according to the commutative rule, is the same as Q or P and Q, right? And according to the commutative rule, that is the same as Q or Q. Q, and P. And according to the absorption rule, remember the P doesn't matter at this point. Whatever P is becomes irrelevant to the outcome per the absorption rule. If P is 0, then Q is 1, the outcome's still going to be 1. If P is 1, Q is 1, the outcome's still going to be 1. If P is, so P becomes irrelevant, the answer is Q. So we were able to reduce that whole long monster function down to a single variable. So in terms of circuits, we've just cut out like 20 circuits, which is a huge reduction if we were building a system based upon this Boolean function. So that's kind of an example of working through a problem. We're going to be working through a whole lot of problems using these same rules. Again, you don't have to memorize the rules, you just got to know how to apply them. If you have any questions, ask in the forum below.